Thanks to the AnyLogic crew for letting me speak another year. As John noted, I'm going to talk a lot about strategy. I'm fully aware that this is a simulation conference, and so I intend to weave a substantial amount of simulation into it. But I want to start with the strategy perspective and then come back to simulation and its role in doing strategy. I want to start by asking a question to this group. How many of you have either been involved in creating corporate strategy, maybe part of a stakeholder group that creates strategy, or has been tasked with implementing a corporate strategy? How many? Raise your hands. Okay, substantial number. So let me ask the next question. How'd that work out for you? Those who thought that worked out very well, raise your hand. I've got two, and they're consultants. They don't count, okay? I know them. All right. Well, the evidence is, and I think what most managers and stakeholders know, is that strategy making is difficult. It's always difficult if you're doing it well. But the traditional strategy approaches have significant limitations that in general lead to not as good of results as firms really need. And the key limit, sort of the high point, or if you want to say the low point of the limitations, really has to do firstly with the static nature of the traditional strategy process. The idea that you're going to create a strategy for a future, the future is considered unchanging generally in a traditional point of view, and that you're going to look at that once a year because, gee, nothing could change in a year, and that the result, that future is predictable in some sort of fashion. And I think we know from our own experience, but also from our studies, that people are unsatisfied with that. Of course, the best judge of that is our clients. When I was speaking with a strategy team at a client, basically with this sort of a presentation that we're going to go through here today, this is what they said to me. And the thing I want to focus on is this concept of failed assumptions. What are the assumptions they're talking about? Well, what they're really saying was the strategy was a bunch of assumptions and not enough insight. And that's because the traditional strategy process works maybe too much like what I would call an engineering process. And the idea in the traditional process is that we're going to predict a future. We, as a stakeholder group, as a strategy group, are going to agree on what that future looks like, what the assumptions are that make that true, and then we're going to find a strategy that would optimize our results. It becomes an optimization problem. Optimize our results given this assumed future. Now that works great for a lot of problems. Those problems are ones where the future is easy to predict, but in general, if you're doing strategy, then the future is not easy to predict, and mostly people with good insight will not agree on what that future is, making execution very difficult. Tversky and his colleague Danny Kahneman, they called reality a cloud of possibility, the metaphor of a cloud for what that future looks like. I liken the traditional strategy process to an idea that we are going to select a single water droplet of that cloud of possibilities. We're going to select that as the one that's going to fall on our head. And then we're going to organize ourselves around that. It's sort of ridiculous even on the face of it. Now, the idea that the future is uncertain, not even remotely new, of course. It's a concept that's been with us really for all of modern times. For sure, our financial industry is based on understanding uncertainty about the future. Of course, financial instruments, insurance, and all kinds of different trading instruments are all based on understanding what they would call risk or uncertainty and managing that effectively. What Tversky and Kahneman observed was when we translated that to the decision-making process that people have in the strategy environment, then a lot of poor behaviors, poor decision-making behaviors become paramount. So when I think about strategic decision-making, I start by likening it back to the learning process. And any study of, sort of deep study of strategy does inevitably get into cycles of learning that the leadership team has. In the traditional cycle of learning, I like to start with the stakeholders' mental model, the set of assumptions that their set of insights or gut beliefs or understandings that the stakeholder team has. And that gets translated through some process. In the worst case, that process may be very ad hoc. And that turns into some set of actions, some set of investments. Those get put into the real world. Stuff happens. We get a result, we get some data, and we get some cycle of learning. That's a great decision process when that cycle of learning can be completed rapidly, in a manufacturing environment, in certain kinds of engineering processes. In the strategy world, of course, the time frames are long. So implementing a strategy could be, and very often is a 5 or 10-year process. And while you're pursuing the implementation of that process, the world's changing. And so if you're not careful, whatever it is you're choosing to do is obsolete almost before you start doing it. And the data you're collecting is not relevant to the strategy you chose. And what makes this even worse is you're doing it annually. I mean, obviously the world is not going to change in a year, right? I'm sure we'll ask that question again. So I promised you there'd be some simulation, so we'll get started now. So obviously the way to accelerate this is to build a simulation model of what you think that world looks like. But that's only a starting point, because what's key here is that simulation model can understand the many different ways, the cloud of possibilities that world in the future may hold. And so by using a simulation model, something more than a spreadsheet, and we'll talk about the limitations of spreadsheet in a bit, you'll see you can generate strategies that are resilient. So as the world is changing in ways that are very difficult to predict, then you can build strategies that are going to respond well to a wide range of those. But you can do even better than that. You can build strategies, if you can test them out fast enough in your simulation world. If you can test them out fast enough, you can build strategies that create option value, that create adaptive strategies, that set up opportunities to reap value in the future by positioning yourself in the present. You don't know what the outcome is going to be in the future. So this starts to take you down what I call a real options thinking approach, even though we're not using the sort of traditional mathematics of that. And finally, continuous execution. It's in the title of the pitch. This is not an annual process. We don't build a simulation model of our strategic environment once a year and throw it away. What we're doing is we're building that, and it becomes the repository of our knowledge and insight and our model of how the world works. And so this continuous stream of data that we're now getting out of the world, that gets baked right into it. Now, I mentioned that uncertainty is not new, obviously, and financial instruments often use it. More often than not, in operations or financial environments, uncertainty is dealt with as risk. And by risk, what we mean is an uncertainty that can be captured and would be broadly agreed on by a probability, some sort of closed form probability distribution. So if I'm building a manufacturing line, if I'm looking at certain kinds of financial instruments, there's a lot of history. I can look at the probability distribution. I can use that to understand the ranges of uncertainty. That's great. The problem is in strategic environments, mostly that doesn't work because nobody has any idea what the probabilities are. And the poster child for that is our healthcare system. If anybody here thinks they can predict with some degree of closed form probability, how the regulations and the market environment is going to change in the healthcare environment over the next 5 years, please come see me afterwards, and we're going to start a new business. The answer is nobody knows. And so with deep uncertainty, this is the idea that we are going to make a lesser claim on certainty. So we're making a lesser claim than if I have a probability distribution. And I'm going to bake those into scenarios. And I can start by saying, I don't really know which one of these scenarios is going to play out, but I'm going to look at the entire sweep of those, and I'm going to develop strategies that are resilient in the face of as many of those uncertainties as I'm able to craft my strategy for. Now, I want to start next by showing you what this looks like from a strategist's perspective. So I'm not going to start by showing you a simulation. I'm going to start by showing you the result that we show that our strategy team uses. And what I'm going to show you is it's mocked up in the sense that the data is bogus, so don't try and go trade on anything here. And what you'll see is that we build a dashboard that allows the strategist or the client team themselves, I think this is playing, yeah, there we go, to navigate through the entire possibility cloud, or at least the parts of it are of any interest. And so we have in the upper left-hand corner, we have actually a set of strategies that I may choose. I have a set of uncertainties, in this case called scenario settings. I have different firms. I have different ways to sort through it. And I start by looking at a summary of outcomes. And this allows me across the x-axis there to look at different strategies I may choose and look at the range of results that I may have. And those results show a different distribution of opportunity on the top end and risk in the sense of the range of things that I may do. In this case, doing nothing would be a bad choice, but there's some trade-offs on the right-hand side. But then the strategy team needs to understand why. And so they start to use the interface to filter and select and understand why of the, I think in this case, maybe 10 or 20,000 different simulations that got run, how is it that different ones produce different results? So we look at it across profit margin, across capital, across absolute value of profit. We look at it across time. We look at it cross-sectionally. So the difference here is instead of looking at, say, the time series animation, which we also do, although I'm not going to show you an example here, then what we're really interested in is a very sophisticated comparison style analysis that allows the strategy team to select the best couple choices. And I think just engagement-wise, what we do there is we include the client stakeholder team, right? So this is something the client stakeholder team can do. This particular one's implemented in Tableau. It could be other tools. But and then finally on the screen here, we're actually exposing some very detailed underlying levers in the model so that the client team can do the what if. What happens? And so we said, well, it's sort of called a design your own strategy in the sense that they can understand what the different choices are, how they interact. They get the client team gets a shared mental model out of this process that they can then use to act and increase the confidence. In my opening slide, I said, gee, people don't have confidence in these strategies. This is a way to give you confidence. Now, I will say to strategists, people who are deep thinkers in strategy, they're not typically as analytic as probably anybody in this room. And to them, this is a great playground. They think this is a simulation. But of course, the simulation was built and run, and this entire interface was populated, and then there's no sort of real-time simulation of that. So behind that result, behind that deliverable, is a sophisticated simulation model. And so I told you I was going to talk about simulation before we got done. And these models are hard to build. And in the consulting business, at least the part of I'm in it, it's all about fact-based businesses. And so, or fact-based analysis, fact-based simulation. So where do we get the facts about the future to put into the simulation model? This is the number one question. Well, actually, that's the second most popular question to me. The most popular question is, why can't I do this in Excel? But the second question is where do you they always say, you just made up whatever was on that interface you just saw, you just made that up. You guys go back in the back room, you make it up, and then that's the result. So where do we get the facts about the future? So let's talk about facts for a little bit. I like to build this up. Mostly when people think about facts, they think about numeric data, especially if you're an AI practitioner. Because what you really want is a massive data set of infinite size. You can see on my chart here, I'm going out the top of the chart. We are buried in data, big data. We have transactional data. We have data of cats, images of cats. We've got every kind of data. And for lots of applications, that's very interesting because we can use ML tools, AI tools, traditional statistics, image recognition. I can do all kinds of stuff with all of that data. The problem with that data is it's about the past, and strategy is about the future. And if you care about interesting strategy, then the strategy about the facts about the past no longer map into the future, at least this kind of numeric data. So that may be useful to us, but it's not enough. Now, even looking historically, there's a whole body of information, a whole body of what we would call facts that are non-numeric, that are often ignored in looking at analysis. Non-numeric, I call it structural data. Sometimes people call this knowledge or knowledge-based data. It's knowledge, it's information or facts about how things work. And the best way to be really concrete about that is cause and effect sort of fact. It's processes, it's process descriptions. So facts about so what about the facts about the future, right? Well, I would say that we rely more in our simulation modeling about using non-numeric data in our simulations. Particularly, there's a lot of that we would accept as fact. And those would be things like economic and physical rules, physics of the world, things like this. There is a lot about the future that we would take as under our control. So we're either going to build the plant or we're not going to. And then we have the piece of facts we call deeply uncertain. And those are the things that we have to be resilient against. Now, on the other hand, we still have significant numeric data extracted from the massive amount of numeric data that we have. But mostly, it's parametric in the sense it's parameters to the way that structure works. And we still have a little bit of risk that we can use. So, I like to focus on the model. The bulk of the model is based on facts, things that are accepted as fact. And I like to tell the story of my daughter when she was a freshman in college. She called me up one night. She says, "Dad, I have to write a paper for my philosophy class. And the question is, how can I prove the sun is going to come up in the morning?" I said, "Well, you can't prove it. You can't prove it's going to come in the morning. There's a lot of history that suggests that it's likely, but you can't prove it." And she's like, oh my God, the world's going to come to an end. I said, no, that's not what that means. It just means that we're going to accept it as a fact, but it's not a fact because it is the future. All right, so we build these simulations differently than I think much of the way people talk about simulation. Certainly it's different than process modeling. And the key point here is these models, any interesting strategic model is going to incorporate a significant feedback process. This comes right out of a system dynamics point of the world, point of view on the world. That underlying driving feedbacks then create complex endogenous behaviors in the system that you're modeling. It's not us in the back making up that answer. It's the interaction of the structure of the system with whatever the set of the parameters are. But what we've learned, what we've been doing this for decades, is you can't build these kinds of models using system dynamics, at least not very often, because you can't get the level of disaggregate detail that you need in a corporate setting. So we build the models as agent-based models, but the design of the model is driven by the feedback structure of this. And this is why you can't use Excel, right? Because you cannot get that driving feedback insight and capture it and put it into the model. It doesn't work. So to actually execute this, we build an ensemble simulation. We take our deeply uncertain parameters, our risk parameters, our strategy choices, we run that all out. We create the possibility cloud. We can analyze that possibility cloud using artificial intelligence. You see, I got that into the pitch too, so make sure I got all the buzzwords. And then finally, into an exploratory interface of some sort. Now, there is a tremendous opportunity, I think, for AI-driven analysis then to generate and close the loop into what would be optimal strategic choices. How does that work? And so that, I think, is really an absolute cutting edge. I think this will come up tomorrow in the AI panel. But there is a whole class of tools that we could use. Now that we have the possibility cloud, that possibility cloud is huge. It could be, it's millions of simulations with tens of millions of data points in there. So it's very rich. And then, of course, secondly, there's nothing like the old traditional wetware and visualization in order to generate and then go through this learning cycle. Now, finally, we're doing all these simulations. We're looking at all these possibilities. Many of the possibilities are just non-starters. We need to start filtering through those. I love this quote about Daniel Kahneman. No one ever made a decision because of number. I would extend that to say, your client does not care about your data. They do not care about your model. They do not care. What they care about is the story that your data and the story that your model tells. Because that story then is how they make the decision. So for me, I love modeling, but when I start talking about modeling to a client, 99% of their eyes roll up in their head and they decide I'm not their guy. If you tell them a story, they're much more interested. So it's all about finding that story. Gamification, also another buzzword in this, but this is a way, firstly, of organizing the analysis process. In other words, how about thinking about what the strategic context in question is, and then also a way to engage a essentially non-analytic group, a stakeholder group that's essentially non-analytic, and engage them in that storytelling process and help them make a decision. I'm going to close with this. I love this quote, Peter Drucker, 1973. So if you read that text, hopefully some of you have, if you haven't, you should go back and take a look at it. You'll see that Peter Drucker in the 70s was raising these same questions that we raised in the very first slide. The strategy process is not responsive to the needs. The future is uncertain. It's static. He raises all these things. what he did not have and could not give us was a set of tools that allowed us to address these problems. I think we have those tools now. The simulation process, feedback, the big data, the knowledge of how to interact with a strategically oriented stakeholder group. All these components have to come together to do good on this. And so with that, it's flashing at me. I'll stop and take questions.
So you talked about the strategies, risks, and how that goes into the cloud. When there are infinite number of strategies that you could apply, and there's infinite points on the cloud, how can we, with the limited given time, and the time is the key factor there, we have to deliver something quickly. What would be your approach on these infinite possibilities to kind of choose and select one or few that really makes sense?
Right. So I think if I understand your question is, go back. So we can't, the possibility cloud, well, firstly, let's just look at the metaphor of the cloud. A cloud is a contained holistic structure, right? So there's some part of it that you're in and some part of it you're not, right? So the question is, so how do we think about what's the range of inputs that make some sense? And of course, not all futures, not all possibilities can physically happen. So if you take so we start by saying there are facts that we are going to take, or there's information we're going to take as factual about the future. This is structural. So there's things about the physics of the world that we can't break. You can't act on information you don't have. You can't do something with an object that you don't control or exist. I mean, there's a whole just simple things. And what we find in simulating strategy is when we start to constrain the problem by the physics of the world, then it's amazing that the edges of the cloud start to become much more structured. And then there's the question about, well, so what am I willing to believe? And there's some range of things that different people may want to explore. But it's actually not that hard to start to find the edges of what is interesting in that space. Or I say it's not that hard if you do the work. It's doable. And then you have what I think the key to this is you really have to mine the feedback loop that's on the screen right there. Generated strategy ideas. Once you understand how that system is working, either through our own insight and supported by analytic tools, we can start to find strategies, particularly adaptive strategies, option-based strategies, that can really perform well given a very wide range of conditions. So people say it could be, the range of possibilities is infinite. Not practically. That's not practically true. We just have to get to that point.
I have a question about how you explore this possibility cloud with a team. So you had mentioned before that one of the goals of modeling is for the team, whatever your client is, to be able to challenge their assumptions.
Right.
And so, but you also had mentioned that strategy, people who make the strategy, they're not necessarily interested in the model.
Yep.
They want the story, not the number. So can you talk a little bit about, I don't know, do you rely on like interdisciplinarity? Do you have conversations via Skype where you show different? So what's sort of the logistics about how you generate collective knowledge from people who know different parts of the system?
Yeah, well, that's a great question. So it has to be a combination of a subject matter expert in, of course, subject matter expertise in the industry or situation you're interested in. It needs to have someone who is used to thinking strategically. There's a whole thought process around that is not inherently sort of analytically driven. It's more insight driven. And then it needs to include a simulation modeling team that is able to capture the ideas that are coming out of those into a simulation model that accurately reflects the structure of the business at hand, or of the strategic situation, right? So what does those facts about the future really look like? And then, of course, it's supported by data, data analysts and all of this. And then finally, if you look at the chart on there, there's right at the top of the little triangles, output metrics. What is it we care about? This gets into an awful lot about just framing up the question correctly, right? What do we care about? What are the types of choices that are we even willing to consider? And so it is definitely cross-functional in that sense. It has to be diverse. It really needs a diversity of opinion. It has to be fact-based. This is where someone already said today, people have an intuition about how the system works. Usually some fraction of their intuition is correct, and usually a substantial fraction of it is not. Right? So you have to be able to get to some sort of fact-based implementation that allows them to explore that and understand the story about why it is that it is the way it is.
Fascinating conversation. Can you maybe tell us a little bit more about when you do give your clients these kind of options, how well are they prepared to actually make the decisions and take the actions, given that the actions that they're taking may take years or decades to actually produce results?
Right. Well, that's always an interesting thing. Firstly, you would want the stakeholder team to be involved, early in the process, right? So that helps in terms of socializing things. But you have to remember, they're going to make this decision. They're going to make a decision no matter what, right? So when we looked at that, the very first thing or the very first learning cycle loop, the question becomes, does this give the stakeholder team the ability to make a better decision than they would have made otherwise? Because they're going to make a decision. And as Kahneman and Tversky pointed out in sort of a behavioral economics way, a lot of times the decision they would make is to defer the decision, but that's a decision in itself, right? So obviously it all depends on the specific case and the individuals involved. But when you can engage the stakeholder group in the exploration of all the alternative stories, all those alternative stories, they are going to gravitate to some set of good choices, and they are much more likely to be able to execute on that. A, because they have better choices. B, because this whole process leads to an alignment of stakeholder understanding, which you don't get through most other techniques.
Thank you.